Dear students, in this part we are going to solve few previous year IIT-JEE questions based on this topic. As you know, the chapter is incomplete without solving the problems on it. And therefore, I have collected few different types of questions from this chapter. So let's start with the questions. Hello students, in this part we are going to solve some previous year IIT-JEE questions. Right, so let's start with the question number 1. Question number 1. A radar has a power of 1 kilowatt and is operating at a frequency of 10 gigahertz. So the frequency of operation of a radar is given and also the power is given. It is located on a mountain top of height 500 meter. The maximum distance up to which it can detect object located on the surface of the earth. So basically, if we try to figure out the problem, so we are there is a mountain. On the top of the mountain there is a radar, okay, and the height of mountain is 500 meter, and we have to find the maximum distance up to which it can detect the object lying on the earth's surface. Right. First of all, if we see the frequency of an operation of a radar is 10 gigahertz, that means the propagation characteristics will be of line of sight, right? So there will be a line of sight communication will be there in the radar system because the frequency is this frequency band is lying in the range of LOS region or direct wave. And we have seen the the relation between this maximum range, okay, and this antenna height is so range is equals to, so maximum range is equal to under root of 2 RHT. So here R is the radius of earth, HT is the height of antenna. But in our case, there is not an antenna, we are having a radar, okay, and it is located on the top of a mountain. So basically the distance from the earth's surface up to this transmitting unit, okay, this is basically we will consider as an HT. So this is given to us is 500 meter. Okay, so we can put the values here. So range will be equals to under root of 2 into R, radius of earth, is equal to 64 into 10 raised to power 4 in meters, into height is given to us is 500. If you simplify it, you can take 8 common as well as into 10 raised to power 3. So this under root of 10, this will be the meters. If you convert in the kilometers, it will be roughly equal to 80 kilometers. Right, so the correct answer will be option number A for this question. Moving on to the next question, question number 2. Statement 1 says that sky wave signals are used for long distance radio communication. These signals are in general less stable than the ground wave signal. Statement 2 says a state of ionization varies from hour to hour, day to day and season to season basis. Okay, so there are 4 options given to us. Option A says statement 1 is true, it means statement 2 is also true, and statement 2 is the correct explanation for the statement 1. Statement 1 is true, statement 2 is also true, but statement 2 is not the correct explanation for statement 1. Option C says statement 1 is false and 2 is correct. Option D says statement 1 is true and statement 2 is false. So if we see the two statements, statement 1 and statement 2, first of all, if you see statement 1, in statement 1 they are saying that the sky waves are used for long distance radio communication. And in our this lectures we have seen that basically sky waves can travel around the world. And I also explained you that if we take the earth and if we are having two antennas located on the different side of the earth, so using this sky wave, even they can travel, okay, so they can travel at a much more larger distance as compared to the surface and the surface and the direct wave case, right? Therefore this statement is correct. Second thing, we see that they are saying that the signals are in general less stable than ground waves signal. So they are saying that the sky wave signal is less stable than ground wave signal. In the statement 2, they are saying that the state of ionization varies from hour to hour, day to day and the season to season basis. So they are exactly right. See, the sky waves are less stable because the state of ionization varies. Okay, from time to time, that is hour to hour, day to day, in the season to season basis. Therefore, the sky waves are less stable as compared to the ground waves. Therefore, statement 1 and 2 both are correct, and the statement 2 is the correct explanation for the statement 1. Therefore, option A will be the correct answer for this question. Moving on to the next question, question number 3. If a source of power 4 kilowatt produces 10 raised to power 20 photon per second, the radiation belong to which part of a spectrum? The radiation belong to a part of a spectrum called X-ray, ultraviolet rays, microwaves and gamma rays. So basically for this, first of all we have to determine the frequency. What is the frequency of frequency for this radiation? If we are able to find the frequency, we can easily figure out the in which spectrum it will lie. I mean the spectrum will be either for X-rays, ultraviolet rays, microwaves or for gamma rays, right? So first of all we have to find the frequency. So first of all, if we remember the relation between power, photon rate and the frequency, so the relation is power is equals to photon rate into HF, right? So from here the frequency will be equal to photon rate, that is 10 raised to power 20. For the frequency will be equal to power, that is 4 kilowatt, okay, and divided by photon rate, that is 10 raised to power 20, and H is a Planck's constant and the value is 6.023, right, into 10 raised to power 34 minus 34, right? So if you calculate this, the frequency will come out to be like around 6.02 into 10 raised to power 13. So in this range it will come out. So if you see, this is basically range of an X-rays. This is the frequency lying in the band of X-rays. Therefore, the correct answer for this question is option A, that is X-rays. Moving on to the next question, question number 4. So here we are given a two lists, list 1 and list 2. List 1 contains electromagnetic wave type and list 2 contains its its application basically. So you have to match them correctly, right? So first of all, see the waves we are given is the infrared ray waves, radio waves, X-rays and the ultraviolet rays, right? So ultraviolet, X-rays, radios and the infrared. And if you see the options, applications given to us is to treat muscular strain, for broadcasting, to detect fracture of bones absorbed by the ozone layer of atmosphere. So if we start with the simplest one, so we all have been knowing about the X-rays. The application of X-ray is to detect the fracture of bones, right? So many of you might have had a fracture and go for the X-rays to detect the fracture of the bones, right? So therefore the application of X-rays is to detect the fracture of bones. The next is here is radio waves. We have seen that the radio waves is used for the broadcasting, because in radio waves we are not having a wireline channel, we are having a wireless channel, that is a radio channel. So the signals can be sent in any direction. That means the signal can be easily broadcasted. Therefore the radio waves are used for the broadcasting. If you see this last one, fourth one, ultraviolet rays, okay. So this is also, we know that the UV rays are absorbed by the ozone layer of the atmosphere, okay. And the last one is left is the infrared waves, that is used to treat the muscular strain, okay. Therefore all are correctly matched, okay. So this will be B, C and D. So we can see A should be first, B should be second, C should be third and D should be fourth. That is the correct answer for this question is option number 2. Moving on to the next question, question number 5. Again the question number 5 is of the statement type. We are given the two statements. Statement 1 is they are saying as the surface wave and the sky wave cannot be observed on the moon. Okay, surface and the sky wave cannot be observed on the moon. Statement 2 is saying the atmosphere of variable refractive index is required for propagation of surface and sky wave, right? So we have to see that which is either both the statements are correct, or any one of them is correct, or any one of them is wrong. So these are the four options given to us, A, B, C, D. Let us see first option, statement A. Statement A is given to us is surface in the sky cannot be observed on the moon. That is actually correct. We have seen that all types of wave, whether it is a surface wave, direct wave, or a sky wave, okay, all are not crossing the ionosphere layer, right? So they are only within the our Earth's atmosphere. Therefore, they cannot be observed on the moon. Therefore, the statement 1 is correct. Whereas if you see the statement 2, this is also correct. In the statement 2, they are saying that the atmosphere of variable refractive index is required for propagation of sky wave. We have seen that in case of sky wave basically, in case of sky wave, the waves are going towards the ionosphere region and they are reflected back from that. And the reason for the reflection was because of the variation in the refractive index. The refractive index of the different layers within the ionosphere is changing and it is decreasing basically. Therefore, there is a bending of waves takes place, and thus so if you consider this as a Earth surface, so when the signal goes from the transmitter, okay, let's suppose this is a receiver. So when it goes to the ionospheric region, okay, so the bending takes place in this ionospheric region, and it come back to the receiver. And this movement, or we can say this bending of waves, is due to the variable refractive index. Therefore, and this is the only reason why the waves are not observed on the moon, right? Otherwise, they might have crossed the ionosphere region and observed on the moon also. But due to this variable refractive index, these waves are refracted back towards the Earth's surface, right? Therefore, statement 2 is correct and is the correct explanation for the statement 1. And therefore, the option A is correct, right? So, all this about this chapter, I hope you all have understood this chapter. If you still have any doubt, you can post them for free on our website askIITians.com. Click on the option Ask a Question. After clicking over here, you can select the category of your doubt. After selecting your category, type your doubt over this box, and if you want to attach an image of your question, you can also do that by clicking over here. After this, click on a button Ask a Question. The expert at askIITians will answer your doubt within 24 to 48 hours. Hello students. So in this video lecture, we have studied about communication systems. We have started with the definition of communication system. In the first part, we have studied about the block diagram of communication system. We also studied the different working application of each and every element in a communication system. In the second part, we have started with the communication channel. We have seen how the propagation of wave takes place in case of wireless channel. In the third part, we have started with the concept called modulation. What is modulation and why it is required in case of an communication system. In the fourth part, we have started with the concept called amplitude and frequency modulation. We have also seen the effect of modulation index in case of amplitude modulated wave. So I hope you have understood this chapter in a better way. For more videos, stay tuned with us. Thanks for watching this video.